So now we're going to turn to variations, different ways to do randomized experiments, and we're going to talk at length about the generalizability of randomized experiments. That's, someone or you did a randomized experiment, it got some results. To what extent can we interpret those results as applying to some different setting, time, place, context? So randomized experiments can take place in a wide variety of settings. Of course, you could do them in an actual lab or some specialized artificial settings, which enable you to control lots and lots of aspects, other variables. Kind of the polar opposite are field experiments, experiments that take place in real-world settings. Schools, businesses, neighborhoods. So that very influential older experiment that we opened with about time limits on cash benefits was an example of such things. And of course, there's a very long tradition of randomized experiments in medicine, often called randomized clinical trials. People even call education and labor market experiments, RCTs, randomized clinical trials as well, or sometimes randomized control trials. The point about these is that they're taking place in real world settings. This takes a lot of time, a lot of organization, but as we're going to get to soon, that certainly enhances their generalizability. There's also something you see, survey experiments, where people doing a survey are randomized to get different types of experiences. There they'll get different questions. You can see how the effect of different question phrasing and so on. And then finally, don't have it in the slide yet, but you can do randomized experiments online. And to the extent that we live online now, that's, great. It's kind of like the field. Doing randomized experiments online, whether as part of a survey or in a real world setting, you can do a lot of things you couldn't do even very recently. You can show people different videos. You can have them play interactive games and do all sorts of things. So there's a lot you can do with online randomized experiments, including in the middle of surveys. So one thing I want to talk about in terminology is random assignment versus random sampling. You remember we mentioned that in sampling before you even knew what random assignment was, or perhaps you didn't know, perhaps you did. And the point I made then is focus on the second term. So as you recall, random sampling uses chance, random numbers, to select a subsample from a population, and that makes the results more generalizable to that population because your sample is representative of the population. Random assignment uses chance to assign the study subjects to treatment and control, making them comparable to make valid causal evidence. So here's a way of depicting how it all fits together. Imagine some population you want to study. If you have random sample from that population, it'll be representative and give you good generalizability to that population. I'm going to talk soon about generalizing to some other population. Now your sample or your study subjects, which if you randomly assign them, you'll make your treatment group and your control group comparable, the same on average, as we said, and that provides good causal evidence. Of course, many times we have random assignment without random sampling, or random sampling without random assignment, as we did in a lot of the observational studies we saw. So your ideal study has both random sampling, giving you great generalizability to that population, and then randomly assigning people to get good causal evidence. That was rare until recently, but now you see if people can do online survey experiments where they get to sample from a well-defined population, you do see this more often than you used to. Okay, so now let's talk about one of the biggest drawbacks of randomized experiments. Their limited generalizability. So remember that generalizability is also known as external validity. I know there are like a gazillion uses of the term validity in research. That's why we prefer the term generalizability, but external validity is also a really useful term because it makes clear that you did your study in some place, some time, some context, etc. And you drew conclusions from your study. And what you want to know is if those conclusions are relevant to some external setting, some other time, some other place, some other context. So let's talk about randomized experiments. Many of them are expensive and difficult to mount. Not these online ones, but a lot of the big picture policy ones. What does that mean? You've done them in specific places, specific times. If you're running a randomized experiment in a recession or an economic boom or during the COVID pandemic, those results may not generalize to some very different setting if some aspect of that time and place is relevant to the treatment, its outcomes, and especially the mechanism through which the treatment or program affects the outcomes. A lot of businesses these days try to run randomized experiments that are not limited. They call them A/B studies, A/B. And particularly when they run them online, they'll be like, oh, we have the model's hand this way or the model's hand that way. And they run a lot of them with incremental changes so that they're not limited in settings, in time, and in place. But the big, expensive ones that are often done in policy, in workforce, in education, in medicine, they have their limitations. Second big thing that limits the generalizability of randomized experiments is that it's people who volunteer. Even if you sample them systematically, which few can do, often they just go out and they're asking for volunteers or getting people to recruit for them. The people who volunteer, the people who are willing to consent may differ from what you would get otherwise. And if they differ in a way relevant to the outcome in the study, and especially if they differ in ways relevant to the mechanism through which the program works, it's a problem. Your results may not generalize to any known population. You have people who were particularly interested. So think about example like trying to recruit research subjects to participate in a study about breastfeeding promotion. So you have women who are pregnant and they're recruited, say like, hey, would you like to participate in a study? You might end up getting a peer counselor who could help you learn to breastfeed. Would you be interested in being in such a study? This is an example from a study I really like by Ted Joyce, owner Altendag, Julie Reeder. Talk a little more about it soon. So this was in an administrative setting for participants in the WIC program, and they were offered an opportunity to participate in this. And so think about this. What kind of women are like, oh yeah, that'd be great. That would be something I might really like. And others are like, yeah, no, thanks. I don't want to be in that study. Well, women who are interested in breastfeeding, especially if they've not done it before, or they've had problems before, or they're worried about it, but they're very motivated to do that, and they know that they will be able to do that, that they're not in some workplace setting that makes it impossible, they're like, oh yeah, that'd be a nice study. Whereas other women are like, no, I do not want to do this, or no, I know I absolutely can't do it, it'll be impossible at work. They don't want to be in some study where they might end up in a situation where, you know, some woman like them, a former WIC member who was as successful at breastfeeding is calling them and like, oh yeah, I don't want to be hassled about that. So therefore you might think that even if you start with a well-defined population, the people who agree to participate are not going to be representative of everybody, and in a way that's relevant to what you wanted to do. They weren't interested in that case in looking at the effect of this peer counseling on actual breastfeeding. It's a really interesting study. I recommend it to you. So there are many parts to it, but long and short of it is among the white WIC recipients, not among the Hispanic ones, they found that basically pretty much everyone who agreed to be in the study was breastfeeding, and those who didn't agree to be in the study were not breastfeeding, suggesting you're having some serious bias, not in your causal effect. Well done, randomized experiment, great causal effect among those who participate, but in who participates, right? So going back to this part, the population to the sample was what was having bias. Okay, so what about some other limits about the generalizability? Well, oftentimes the randomized experiments are done by researchers who have a real interest in what they're doing. And so they really want to, they want this to work. Maybe they develop the intervention, the program, they care a lot about it. And it's in some very motivated setting. They may have very motivated staff to actually implement the program, better funding, all kinds of things. So a lot of things can make implementation of the randomized experiment, implementation of the program, of the treatment in our randomized experiment, different than what it's like at full scale. And indeed, I know from people who've run randomized experiments that, often they've been doing an experiment and they're actually going to be able to continue with the program afterwards, but it's just going to be sort of a real world thing. There won't be random assignment. People can choose, and the staff are like, oh, now we can relax. We've been working so hard to do this so well for this study. Never mind all the times when you go to full-scale implementation, you have much worse funding, less trained people who have to see more clients, work with worse equipment, etc., etc. So that can undermine the generalizability. There's also a concern about the long-run effects. Often when you do a randomized experiment, you're doing it at a small scale. It's a new thing, right? That's why you're doing an experiment. It's not established. You don't know if it works better. You're trying it out. You're seeing if it works better. If you knew it worked better, it might not be ethical. Probably wouldn't be ethical to do the study. But that means that it's on a small scale and people don't expect it and it's new. And so you don't have the long run effects. You don't know what it's like when people expect it. So let me give you a couple of examples of that. So one is about mandatory arrest for domestic violence. And we have that as an example in the book. So I think it was in the 70s. It wasn't a common thing, you know, if the police got a domestic violence call, they came, but if the victim did not want to press charges, that was it. They didn't press charges. There was some idea that that was not a good approach, and they actually did a randomized experiment where police who went out were randomly assigned in some cases to have a mandatory arrest. And because it was new and it wasn't expected, you know, that didn't affect things like the likelihood of calling and so on. And they in fact found that the mandatory arrest reduced domestic violence related homicide rates. It was quite successful. For a wide variety of reasons over a long period, really decades, and definitely not just due to this experiment, but a lot of changed thinking about domestic violence, mandatory arrest became very common. It came in at different times in different places and so on. As a result, researchers were able to use the kind of techniques we're going to talk about in the next chapter with the natural experiment. And there was a study, Iyengar showed that the reduced homicides did not persist for a long period after widespread adoption. Now, the Iyengar study didn't prove why, but one potential reason that is consistent with some of the other evidence she found is that victims know after widespread adoption that if you call the police, there's mandatory arrest, assuming the police think the situation is worthy of that. And that could affect their likelihood of calling the police. As I say, the study doesn't show that that's what was going on, but it's a possibility. And the point is that in a real world setting where everyone gets to know about an intervention, react to it, and make long-run adjustments, the results may differ. Economists have some jargon, general equilibrium, which means, you know, all the different actors have adjusted to the change. But it's a very important one to remember. Let me give you another example. We talk in the book about the Rand Health Insurance Experiment, very influential study from the 1970s to have more cost sharing, like deductibles in health insurance plans. And that basically showed, there are a bunch of qualifications, but in many ways it showed people use less care without it affecting at least a number of important health outcomes. And it was influential. It's part of the reason we have such high deductible plans, certainly not the only. But at the time they did it, those high deductible plans were not very different. Doctors and other clinicians didn't expect it. Everyone wasn't used to it. Now everyone's used to high deductible plans and they expect them and react to them and are prepared for them, so they may work differently. So now we're going to turn to how you can assess the generalizability of a particular study. So the first thing you do is describe the place, the time, the context, the group, everything about the population being studied. Not just, high school students, but you know, what high school, where, when, how, all of those things. So that determines the population being studied. And what we talked about before was trying to figure out how representative the study subjects are of that population of interest. Were they randomly sampled? How did you get them? And how representative are they of that population you want to know about? And of course, that's important, as you know, we were just giving examples. But now I want to do something different. I want to talk about how you assess the extent the results generalize to other populations, other contexts, other treatment implementations, other places, other times, etc. You know, so we're just talking about some problems that can exist in such settings. So first of all, this is more craft or even art than science. This isn't like, you know, calculating a t-statistics. It also is something that is going to depend on your expertise, your outside knowledge of the population, of similar populations, and especially of your program and its mechanism, how and why it would affect the outcome. So for example, you know, if you are interested in the effect of a particular educational intervention to help people, and you do it in, you know, a particular elementary school in some well-off suburb, and you want to know, hey, is that program going to work in my, you know, poor rural elementary school? You got to think about the mechanism. You got to think about whether the mechanism is going to be different, is going to work differently in that poor rural setting. So you need to focus on what kinds of variables are important, what kind of external contextual variables might affect the links in between. So we're going to have a bunch of examples of this in class. It's not perfect. You know, you can assess it, you can even be good at it, and you can be wrong, but it is an extremely important skill, especially for policymakers and practitioners, people who are not so much producing research as consuming research. You know, you see a study, it has an impressive result, and you have to decide, okay, would that work for us? Should I put the money and time and effort into implementing that? That's about would it generalize. So now we're going to turn to some variations on how to do experiments, different ways. So the first one I want to discuss is a very important one, cluster randomization. That means you're randomizing clusters or groups of people or groups of whatever it is you want to know the effect of. So for example, you know, if we were talking about an educational intervention, you might think, oh, we'll randomize students because it's students whose outcomes we care about. Or if we have a medical intervention, we'll randomize patients. Often that is not practical. There are a lot of problems with it. And so people instead randomize clusters. So that could be randomizing all the students of a particular teacher. That could be randomizing entire schools, randomly assigning schools to different teacher and controls. Things like that. So again, you've got a group of people and you're randomizing all of them together. So what are some good reasons for that? and some bad reasons. So I just gave you an educational example, a really important example. Some of the best evidence about the outcomes of breastfeeding come from a randomized cluster experiment or randomized cluster trial in Belarus to promote breastfeeding. A lot of breastfeeding promotion examples I've got today. So basically, they took entire hospitals and maternity clinics and randomized them so that the staff, especially the nursing staff, I believe, either did this intensive promotion of breastfeeding or there was just the usual practice, what they were doing. So you can imagine that reduces leakages. Imagine instead you tried to do this by randomizing the mothers and told all the clinicians, oh, hey, this mother you're going to promote the breastfeeding to. This other mother, you're just going to do what you've always done before. And, maybe they're nearby within the hospital. How are the clinicians going to remember this and keep it straight, who they're supposed to do what to? And if they really believe they've been convinced that the breastfeeding is better, then, oh my God, they're going to feel bad not promoting it. Okay, so that's impractical. So one of the jargon is leakage. What I just described was leakage from treatment to control. You do it in separate hospitals, separate maternity clinics, separate staff. You don't have that problem. This also captures both positive and negative spillovers. So if mothers get to know each other, either during hospitalization, they're in the same area afterwards, you see both positive and negative spillovers of them talking to each other. And it's practical in many, many settings there are all kinds of things where it's completely impractical to randomize the group, the participants whose outcomes you care about. But it does have some disadvantages. The biggest disadvantage is balance, the apples to apples, comparability of treatment and control. Think about that breastfeeding promotion study. To get balance, you need a lot of hospitals and maternity clinics with thousands and thousands of mothers to get balance. Why? One hospital is in one particular place and its patients, its service area is very different than another. And so just by chance, if you only have a few hospitals and maternity clinics, it's going to be imbalanced unless you have lots and lots of them, which becomes very expensive and very difficult. And in fact, although that study is very important and very influential, in fact, what they found is that purely by chance, the breastfeeding promotion arm had a few more mothers who smoked than in the non-breastfeeding one. And there are many people who are skeptical of some of the results because of that imbalance. It's not a systematic imbalance. It's not like, it's not like it was some smoking reduction, or there was self-selection, or there was self-selection into mothers who, are less risk averse. It's not like that. It's by chance, but you can get imbalance by chance if you don't have a big enough size. Another variation is the number of arms, which I referred to. So we're talking about treatment versus control, 2 arms. And a lot of times, even if you have 2 arms, one isn't control. Sometimes for ethical reasons, it's considered not really fair to give one group something that might be valuable, you don't know, and the other group, they get nothing new valuable. So sometimes you'll see an experiment with 2 arms that won't have the usual practice, or won't have get nothing as the control. It'll just have 2 different treatments. You also see a lot that have more than 2 arms. So in the textbook, we talked about a very influential study called Moving to Opportunity. And these were households who lived in poor neighborhoods, and they were randomized, if they agreed to participate, of course, into one of 3 arms. One group got housing vouchers that only work in low poverty neighborhoods. If you have to move to a neighborhood with very low poverty, otherwise, the vouchers wouldn't apply. Another group got vouchers that worked in any kind of neighborhood. And finally, the third group got no housing vouchers, or nothing above what existed in, the regular non-intervention world. They were the control group. So that's 3 arms. So your baseline descriptive statistics, your results, 3 columns. Housing vouchers for low poverty neighborhoods only, housing vouchers for any neighborhoods, and control. Although often people were most interested in the main treatment and comparing it to control. Another type of variation you see in the design of experiments is a dose response. Okay, large class size versus small, but how large? You could have a bunch of different doses, different size classes. Of course, each is a different arm. That randomized experiment study that I was referring to, it had multiple arms because the arms had different amounts of cost sharing, different size deductibles, from none to what were large ones at the time. So again, different doses, different size deductibles to see if those had a different effect on spending or on health status. So now we're going to talk about a variation that makes use of what are called factors to probe interactions. So a basic randomized experiment looks at the effect of just one treatment, or more exactly, just one bundle of treatments. Remember, every way that the treatment and control differ in what was done to people. But often we think that we'd like to get more inside the black box and understand how different types of treatments interact. So I'm going to show this with a made-up example, a variation on the moving to opportunity. As I was saying, that the people who were in the group that has housing vouchers that would only work in low poverty neighborhoods, part of the intervention is that they were actually given some help in finding such housing, and finding low poverty neighborhoods with landlords who would take their vouchers. That means that we couldn't disentangle the effect of giving people vouchers that only work in low poverty neighborhoods and actually helping them find that housing. Supposing you wanted to look at those effects separately and see how they interacted, you could have a study like this. It's a 4x4. You have basically 4 arms here. One group, no voucher, no help finding housing. Control group we had before. Another group, the voucher for the low poverty neighborhood, and help finding the housing. That was the main treatment group in the actual experiment. But now we've got 2 more arms. We have households that get a voucher but no help finding housing. And we have households that get no voucher, but they do have help finding housing in low poverty neighborhoods. housing that they would have to be able to afford, of course. And now we can separate these things out. So by looking at the outcomes comparing outcomes of the voucher and the no voucher group, outcomes, earnings, jobs, they did a gazillion outcomes. We would find the pure effective voucher among those who get no help finding housing. We can also look at the group with no voucher and see the effect of help finding housing by comparing these two groups. And now we can look at interaction. We can see, hey, does the difference between the outcomes of the people who get both and the people who get nothing, is that more than these pure effects of just the voucher with no help or just the help with no voucher? You may remember that from the statistics work as an interaction, like the moderators, right? Does help finding housing moderate the effect of the voucher? So factors in an experiment allow you to look at this, but the big problem is that it's 4 arms, and to get enough precision, meaning narrow confidence intervals, small standard errors, detectable effects, statistical significance, you need a lot more subjects because you've gone from 2 arms to 4 arms. Another variation on experimental design is called a crossover experiment. So the idea is that the same research subject, such as the same person, is going to be in both the treatment and control group. So we contrast with everything we've been talking about so far that's a between subject one. Each subject is in the treatment or control. So obviously you can't do a crossover experiment with every type of, of experiment. People only take introductory statistics one time. If you put them in the control group with the usual way of teaching introductory statistics, and you then want to move them to the treatment group, well, you can't, because it would no longer be their first time in statistics. They already took it. But for a lot of things where, the treatment, quote unquote, washes out, that's what they say in medicine, and there are a fair number of crossover experiments in medicine, you can do this. So you start by assigning subjects to treatment or control, and then they switch. All right, crossover. So example we have in the book is texting and driving on a simulator. And this can be an important technique when subject heterogeneity is really strong, when people differ a lot from each other. And that makes it really hard to get balance if you're doing a between subject study and you have different people in different groups. Kind of like what I talked about with the randomized cluster ones where, it was hard to get good balance because the clusters, like the hospitals or the schools or the teachers, the clusters of patients or students differed. The big drawback, of course, is persistence of treatment effect. I talked about a case where you really couldn't do that, and it can be a problem. You need time for the treatment to, quote unquote, wash out. Okay, so that's it for the generalizability of randomized experiments. A real weakness, and one of the most important things to consider in a particular randomized experiment. And also that's it for the variations, the different ways of doing randomized experiments. Next, it's on to human artifacts and how randomized experiments can go wrong.